Okay, good afternoon, everyone. So today we're going to talk about week 9's exercises. But this is going to be a very quick session because most of the problems are very practical. So I don't think there is much theoretical background I need to introduce. So I will specifically quickly go through some Spark SQL tips I have, and then we move on to JSONiq. Then we directly move on to the Q&A session. Okay. So as we've introduced last week, thank you. No worries. I like the BGM. So last week we've introduced different types of data types, and so in Spark you can organize your data in RDD. Hopefully this is visible. Data frames or data sets, right? And they have different trade-offs. And as I've mentioned, I would highly recommend using data frames or data sets if you can. And this is because they are high-level APIs, right? They are one level above in terms of abstraction, the RDDs. And they have also internal optimizers like catalysts, briefly talked about. Which is also easier to use, I think. So we'll be looking at some of the example queries. But the alternative to SparkSQL is something called Apache Hive. And the only difference is that the underlying execution engine is that, so for SparkSQL, it's using Spark. Right, and I think this thing is using MapReduce under the hood, which is much slower, as I've introduced in the last session. So typically in the exam, you will get a much bigger data set than what we are using in the order JSON lines. And the first thing, typically, I would highly recommend just print out the schema so that you know what kind of nested tables we are dealing with. But yeah, typically this is so-called semi-structured tables because, typically you wouldn't have this nested fields in SQL tables. And then you can do the normal RDD queries, functional interfaces we've introduced previously on these data sets. But what I'd like to highlight here first is that if you were to use the functional interface, first I would highly recommend using the brackets to separate the functions you are calling, right? So surrounding the query with brackets, you can have multi-line structure so that you know at which step you're doing which operation, and also make sure that you don't overwrite the internal functions from Python if you were to use the functions. Otherwise, you need to reload the whole notebook and to get the sum back, okay? So yeah, this is the first point I'd like to mention. Secondly, in SparkSQL, as I've talked about last time, it's using a dialect derived from the ordinary SQL queries from MySQL or Postgres we've learned. So you have a very neat thing, which is this lateral view. What this does is that it allows you to create a temporal view on the fly at runtime to explode a nested view into an independent view. So in this case, what we were having is that we have nested items inside the items column, right? And what the lateral view allows you to do is that it's creating a temporal view inside a query, and the result will be immediately available to the later queries, right? So in the first session, we've talked about the order of execution between each clause, right? And then, so after the from, the select is executed after the from. So all the queries after the from, this temporal view item will be available to all the clauses after the from clause, right? So in this case, it's available to select, and also you can do filtering on it as well. Otherwise, you would have to create a temporal view with width, view, stuff like that, and then execute, which is this way is much nicer, right? And here, another side benefit is that you can use the star filter, sorry, the start operator to so-called unpack that table, right? So it's like in Python, you're unpacking an array, and then all the columns within, for example, in this case, we're unpacking the customer, so it's blowing up the customer to first name and last name, as well as the item to the rows. Okay, I think this is an arrow, yeah. Right. Other things I'd like to mention is, yeah, so here you can compare, you can see for the same query, so here we want to find the most expensive order, and as you can see, it's not very readable if you were to use the functional interface, right? Later, maybe today you wrote the query, and the next day you look at the code you wrote. You might have no idea what it's doing. But I think the reason why I would highly recommend using SparkSQL, is, especially in the exam, is that you can just, hone your SQL skill and use it here immediately, right? It's mostly transferable, and it's very obvious what you are doing because it's much more on the high level. Sorry, question.
Would that be a specific question the exam is saying you have to use the SparkSQL suddenly?
Right. So the question is, in exam, do you have the choice to choose different interfaces? At least, to my knowledge, yes. So last year, we were grouping like the SparkSQL part, or like Spark query part to the same set of questions. So you are free to choose which one you are using. Yeah. Question?
If we're using SparkSQL, can we just write the SQL, or do we need to include like the percent SparkSQL or something else?
Right. So the question is, do you need the line magic here, even in the exam? Yes. So in the exam, you need to use this as well. So basically, you will be provided with an exam box, I think, and it's basically the same environment. And the good thing is that we will release the data set prior to the exam, so you can play with it. And I would also recommend making some questions for yourself to practice. And yeah, basically you will have a notebook to execute. But typically the data set will be bigger, so for a query, it will run like at least 20 seconds to execute. So it's quite expensive to experiment with. One good thing about SQL is that you can show the results much more easily, right? You don't need to do the actions on the RDD. So yeah. Yeah, but and for making the questions, you can try ChatGPT, right? So you give it the schema I've just shown, and then you ask, given the schema, give me some example questions on this data set. Then you can practice it. Typically, the exam, the time is quite short for the questions, and for each of the sections, like for SparkSQL, for SQL itself, for example, each section would have like 10 to 12 queries you need to write, so you need to be fast. That's the only advice I have. Question? Right. So yeah, the question is, how long do you have for each section? Well, I don't have a general answer, but for me, I had half an hour for all the queries. Yeah. So yeah, like 3 to minutes for each query. Yeah. Right. And the next one, so I'm running another Jupyter Lab notebook because my environment is has some problems. But yeah, so for JSONiq, I highly recommend start working on it from this week, because later this will be a big topic, and also there will be 10 to 12 queries more or less on JSONiq as well. And this is kind of a bizarre language. So this week, don't tell other people have said this language bizarre. So one thing I'd like to mention is that you should check out the documentation about the built-in functions you can have, like those arithmetic functions they can use. It's quite handy. For example, you can check the keys in the JSON files and use the distinct values. But in the exam, you will have access to the documentation as well. But yeah, so for example, for this, so these are the built-in functions. And for accessing elements, you can directly use this indexing without a problem, and also accessing the nested fields as well. Right, so for example, in this case, we have each line. So this is the GitHub archive. We've reduced the number of records, but for each record, you will have different types, and you have these keys like type, payload, public, and you can play around with the nested fields. Typically, in the exam, you will have a much more nested dataset for JSONiq than, like, say, SparkSQL, because JSONiq is specifically designed for NoSQL, like this non-structured data types or semi-structured data types. And also you can access the nested field directly. One thing I'd like to highlight here was that, so for example, in this case, you can bind, right? This is not assignment, but you are binding this value, so this literal, to a variable. So this is constant, and you can change to the URL, and you are loading it as we've done before. But what's different here is that you have this $, and what it does is nothing but accessing every single element in the commits. So in the commits, you have several commits in the array, but basically the $, is says that this is representing each and every element in that array. And this is basically a predicate for that selector. This is quite similar to a Panda data frame. So you are putting a selector inside of the square brackets, and to select, I want to return the records that have commits more than 10 commits, right? And to illustrate this further, so you can see, say I'm iterating through 1 to 10, and I'm printing out ×2 values, and you can also put a predicate here to filter out the value that's less than 10, less than or equal to 10. And this is the same for more complicated queries, because JSONiq is functional. You need to always have a single query with a return statement. This is like, you can think of it as the SQL queries. And then in this case, it's doing exactly the same, but you have more mixed syntax with the iteration, right? You are iterating all the record in the JSON file, and you are binding all the commits to this variable, and you are using the where clause to filter out the final return events. So this is doing exactly the same as the above queries. But I have to say the syntax or the kind of logic is a bit different. That's why I would suggest looking at it. This also is doing the same thing. You can just put the where clause is exactly as the predicate or the filter here. But in the where clause, you can have more flexible filtering mechanisms or longer filtering clauses. Okay. And also we can do unpacking. So for unpacking, because if you can recall from previous sessions, there are two concepts. One is sequence, and one is arrays and objects. So you can use an empty bracket to unpack into a sequence. Sequence is always flat, or you can use this nested bracket to unpack into an array, right? So basically, if you put a number inside the double bracket, you are first unpacking the array, and then access one of the elements in that array. Right, so it's this double brackets with an index. Right. So it's so what I wanted to show is that it's a bit different. That's why practicing it from now on, and also creating some queries for ourselves as well. Right. That's pretty much it I'd like to cover. And all the exercises this week are practical, and also from the Moodle exercises. I think there was a question on Moodle regarding the ordering of a Spark RDD query, because you need to order a query with different ordering. One, I think two of the fields you need to order by descending order, and one is ascending. And for that kind of queries, using RDD is very, non-intuitive. So I would highly recommend using still SparkSQL directly. That's it, guys. Next, if you have any questions, just come to me, especially for the queries I've answered. I think pretty much it's by emails, but if you still have remaining questions, just feel free to raise your hand. I will come to you. Yeah, that's pretty much it for this session. Thanks a lot. We've got 2 hours back. Yeah.